Hello. Welcome to Attune University. Here we are going to start our session on Git Distributed Version Control System. Version control or source control is all about managing multiple versions of documents, programs, websites, etc. Almost all real projects use some kind of version control tools. It is an essential for team projects, and also very useful for individual projects. Some well-known version control systems are CVS, Subversion, Mercurial, and Git. CVS and Subversion use a central repository. Users check out files, work on them, and check them in. Mercurial and Git treat all repositories as equal. Distributed systems like Mercurial and Git are newer, and are gradually replacing centralized systems like CVS and Subversion. Version control systems are important for any form of distributed, collaborative development. Whether it is the history of a wiki page or large software development project, the ability to track each change as it was made, and to reverse changes when necessary can make all the difference between a well-managed and controlled process and an uncontrolled first-come, first-served system. Version tracking. Developers may wish to compare today's version of some software with yesterday's version or last year's version. Since version control systems keep track of every version of the software, this becomes a straightforward task. Version control system gives you a time machine for rollback to earlier versions. Version control is central to coordinating teams of contributors. It lets one contributor work on a copy of the resources and then release their changes back to the common core when ready. Other contributors work on their own copies of the same resources at the same time, unaffected by each other's changes until they choose to merge or commit their changes back to the project. You can get great support for different versions, standalone, web app, etc. of the same basic project, and also simplifies concurrent work, merging changes. There are various types of version control systems, but Git is most widely used tool. Git is an open-source version control tool, and it available for almost all machine. Git has many advantages over earlier systems such as CVS and Subversion, like its more efficient, better workflow, etc. Git does not depend on a centralized server, but does have the ability to synchronize with other Git repositories to push and pull changes between them. Git branches are used often and merged often. In many cases, developers will create one for each feature they are working on and merge between them possibly multiple times a day, and it's generally painless. Best competitor of Git is Mercurial. It is competitor of Git because same concepts, slightly simpler to use, and also have Eclipse plug-in, so you have easier to install and use. There are online materials that are better than any that I could provide. Here's the standard one location to download Git. Here's one from Stack Exchange. Git is primarily a command line tool. I prefer GUIs over command line tools, but your developers can also use Git Bash for their development process. Now it's time to introduce yourself to Git. Enter these commands into your Git Bash or command line tool with appropriate changes. Git config, global username AttuneInfocom. In this command, replace username AttuneInfocom with your username. Git config, global user email attune@attuneinfocom.com. In this command, replace email ID with your email ID. You only need to do this once. If you want to use a different name email address for a particular project, you can change it for just that project. cd to the project directory. Use the above commands, but leave out the global. Here we are going to repository on local machine. cd to the project directory you want to use, type in git init. This creates the repository, a directory named Git. You seldom, if ever, need to look inside this directory. Type in git add. The period at the end is part of this command. Period means this directory. This adds all your current files to the repository. Type in git commit m initial commit. You can use a different commit message, if you like. Git clone URL. Git clone URL my path. These make an exact copy of the repository at the given URL. GitHub is the most popular, free, public repository. All repositories are equal. But you can treat some particular repository, such as one on GitHub, as the master directory. Typically, each team member works in his or her own repository, and merges with other repositories as appropriate. Your top-level working directory contains everything about your project. The working directory probably contains many subdirectory source code, binaries, documentation, data files, etc. One of these subdirectories, named Git, is your repository. At any time, you can take a snapshot of everything, or selected things, in your project directory, and put it in your repository. The snapshot is called the commit object. The commit object contains 1. A set of files, 2. References to the parents of the commit object, and 3. A unique SHA1 name. Commit objects do not require huge amounts of memory. You can work as much as you like in your working directory, but the repository isn't updated until you commit something. When you set git init in your project directory, or when you cloned an existing project, you created a repository. The repository is a subdirectory named Git containing various files. The dot indicates a hidden directory. You do not work directly with the contents of that directory. Various Git commands do that for you. You do need a basic understanding of what is in the repository. You do your work in your project directory, as usual. If you create new files and/or folders, they are not tracked by Git unless you ask it to do so. Git add new file 1 new folder 1 new folder 2 new file 2. Committing makes a snapshot of everything being tracked into your repository. A message telling what you have done is required. Git commit m uncrevulated the conundrum bar. Git commit. This version opens an editor for you. Enter the message. To finish, save and quit the editor. Format of the commit message: one line containing the complete summary. If more than one line, the second line must be blank. A commit is when you tell Git that a change, or addition, you have made is ready to be included in the project. When you commit your change to Git, it creates a commit object. A commit object represents the complete state of the project, including all the files in the project. The very first commit object has no parents. Usually, you take some commit object, make some changes, and create a new commit object. The original commit object is the parent of the new commit object, hence, most commit objects have a single parent. You can also merge two commit objects to form a new one. The new commit object has two parents, hence, commit objects form a directed graph. Git is all about using and manipulating this graph. A head is a reference to a commit object. The current head is called head, all caps. Usually, you will take head, the current commit object, make some changes to it, and commit the changes, creating a new current commit object. This results in a linear graph. ABC head. You can also take any previous commit object, make changes to it, and commit those changes. This creates a branch in the graph of commit objects. You can merge any previous commit objects. This joins branches in the commit graph. In Git, commits are cheap. Do them often. When you commit, you must provide a one-line message stating what you have done. Terrible message: fixed a bunch of things. Better message: corrected the calculation of median scores. Commit messages can be very helpful, to yourself as well as to your team members. You can't say much in one line, so commit often. When you commit, Git will require you to type in a commit message. For longer commit messages, you will use an editor. The default editor is probably Vim. To change the default editor, you can fire this command. You may also want to turn on colors. You can fire this command. All repositories are equal, but it is convenient to have one central repository in the cloud. Here's what you normally do: download the current head from the central repository, make your changes, commit your changes to your local repository, check to make sure someone else on your team hasn't updated the central repository since you got it, upload your changes to the central repository. If the central repository has changed since you got it, it is your responsibility to merge your two versions. This is a strong incentive to commit and upload often. Git can often do this for you, if there aren't incompatible changes. You can go through this commands for workflow. Git pull remote repository, get changes from a remote repository and merge them into your own repository. Git status, see what Git thinks is going on, use this frequently. Work on your files, remember to add any new ones, git commit and what I did, git push. In this graph you can see that how Git manages multiple versions of code. When initial commit done, head is on the commit. When you do changes with your code, your head changes, as you can see in fourth commit. You need to merge your code with working repository. If you feel that your code is now production ready, you just merge with central branch and your head will shifted on third commit. If you have any question regarding this session, contact us. We are pleased to answer. Thank you.